Okay, let's now dive into the naive Bayes classifier. Very popular for spam filtering, but also as a baseline for other applications. We will do coding exercise on sentiment analysis, and we will look at 50,000 movie reviews. Yeah. And train a classifier on these reviews, or half of them, because we're gonna split it 50% test, 50% training, for the machine to be able to predict if a rating is good or bad, a rating that the machine has never seen. Okay, so it's quite a lot of data. It's going to be quite challenging. Okay, let's continue and derive the formula for naive Bayes, and we're going to use an example, a spam filter. Yeah. So let's take a test case. We have an email that we call X-test, and that's an email with D words. The words here are the features, yeah? And the words are represented by X1 to XD. Yeah? Remember, the goal of a classification problem is to predict the label given the features. That's the problem that we need to solve. But given the features, given the feature vector X, we can write it as given X1 is word 1 and so on, XD is word D. That's exactly the same. So we're going to try to maximize this, and I will not care about the denominator when applying Bayes' rule, because it's merely a normalizing factor and it does not influence our results. So if we use Bayes now, right, then this is equivalent to, I'm going to swap, is the probability of X1 equals word 1, and then all the way to XD equals word D, given Y is Y, spam in our case, times the prior. Right? As I said, I'm not writing the denominator. So now comes the big trick of naive Bayes. So naive Bayes. Naive Bayes assumes that all the features are independent. So naive Bayes is all features are independent. Is that a why is this naive? Well, usually the features are not independent. Especially when you get an email, there's certain words that gonna appear together with other words. So there is definitely a dependency. So it's naive, but naive Bayes is fast and results are okay. Yeah? It works pretty well. So remember that in statistics refresher we've seen that the chance of AB equals the chance of A times the chance of B, if A and B are independent, right? If A and B are independent. Now what does it mean here? Well, first of all, this here is your email, and this is an email never seen before, in the exact same constellation. Okay? Imagine that here, if we assume that this is spam, yeah, basically this asks us, given the email is spam, give me the email. Can you imagine that you have millions of possibilities? It's very hard to calculate. Yeah? But if we apply naive Bayes, this is equivalent to the chance that x1 is word 1, given the label, times the chance that xd equals word d, given the label, times the prior. So this is a very different case. I can calculate this. What does this mean? It means that given my email is spam, this is still spam, what is the chance that I get to see word x1? For example, this word can be Viagra. If the email is spam, how big is the chance that I will find the word Viagra in the email? So that's a lot easier to calculate. And this is the whole trick of naive Bayes. And basically what we're gonna do is we're gonna look at a few examples so that you get a better feel of what it exactly means.